So welcome to the second class in Big Data Analytics. Just a brief recap of what we did last week and going over what I intend to do for today. Okay. So last week we had a very much descriptive, right? Hands-off thing. You just kind of listen because most of you haven't got the Wolfram Mathematica installed in your machine, which I guarantee, which I am assured that you have already rectified, right? So everybody's got the software installed. Today we're going to be using that fairly extensively. Okay. So last week we talked about the concept of data, right? What's data? Well, data is some kind of quantitative or semi-quantitative, right? In the old days, it was all quantitative, just numbers. But modern days, it's not necessarily quantitative. It could be picture, it could be geolocation, it could be genetic, chemical bonds, it could be voice, that all sort of thing. But the point is that it's a recording of a sample of some kind of population. And the reason you have that as a data is because you want to extract that for information, turn it into insights, so you can do better, serve better, or optimize your service vis-a-vis the larger population. Okay, so you're not interested in particular sample from which the data is drawn. You're only interested because that data sample, okay, is drawn from a larger population, and you are interested in making inference about the larger population. Okay, that's the name of the game. Okay, so you look at the small sample, but your ambition is to be able to understand the larger population. And again, population can be literally interpreted as population, as in when I study a group of students, and that represents people your age, or people your economic background, or people of your educational background, or it could represent a moment in time. So if I study past behavior of certain financial asset, that would be a sample of a larger population. That larger population is the overall behavior of that financial asset well into the future. Okay, so it's across time as well as across individual. Okay, very good. I mentioned that the housekeeping, one of the two ubiquitous data type that I said is going to be very relevant to your lifetime, beside tabular or table data, is graph data. And so in 2 weeks' time, we're going to have a special lecture. Unfortunately, it can only be on Thursday afternoon. Okay, so some of you that would have to miss that class, just send sort of like give your name to the TA. But it will be counted as a regular class, so we'll be taking attendance and whatnot. Graph theory is very much a big area, and I myself, even as early as earlier this year, just wrote this big paper, this research white paper that really involves graph type data. So I can tell you that it's very relevant for my career, certainly, but certainly in the future. So it's a very, very important subject. And like I said, this guy Gabor, Benedek, he's actually Hungarian, and Hungarian have a long history of graph theory. Okay, in fact, the main pillar, the biggest guy in modern graph theory, I can't pronounce the name right, is Erdos. That guy's Hungarian. Okay, so it's very nice. It's going to be a very nice lecture. Again, we'll check the attendance. Unfortunately, I myself will not be here because on that very day, I would be on my way to Copenhagen to present another paper. My research. That one doesn't use graph theory. That one uses Monte Carlo simulation. But anyway, so I'm going to be off to Copenhagen to present that paper to a conference. And that's a commitment that I had prior. And same with this guy. He has a commitment to come to Thailand on Friday. So the only other day he can make is, Thursday. Before that, my presentation, I think it's a Friday or Saturday, but I already made the arrangement, so I can't really change that. So I'm not going to be here, unfortunately, but I'll be watching the recording. Okay, so let's turn to the topic of today. Now, I talked to some length about how data analytics really you need computational platform, right? And professionally, for most of you who are going to be maybe furthering concentration in applied digital intelligence, you're going to have to be using a lot of open source code that's provided in the library, in a huge, global collaboration open library, and that's usually in the language of Python. So you will need that as well. However, for this class and for a lot of you who are not going to be professional data scientists, Mathematica, Mathematica is powerful in a lot of respect, but the main reason I'm using this class is because a lot of interface with Mathematica is very high level. Okay, so instead of having to write 20 lines to set up the machine learning algorithm, train, and so forth, it would be something like a one line to say, build me a classifier. Okay, so it's a top level kind of thing. It doesn't mean that it doesn't have all the detail. It has all the detail. If you're a professional data scientist, like in my work, I can go into the individual option and specify something that's very technical. Okay, but at the top level, it's like if you don't know any better, you go to a restaurant and say, oh, I'm hungry, I feel like an omelet. Okay, so you say, give me an omelet. You don't have to specify a particular way of making an omelet or souffle. It's sort of like a standard default. And on top of that, it's very good in terms of interactive visualization. Okay, this is something that even in Python, it's a struggle. You have to use like an external library, and sometimes it's not very conducive to the work. Okay, so today we are not going to cover anything that has to do with data analytics per se, but we are actually going to get you situated in the software platform. Okay, so what I'm going to have you do is, well, actually, this is a notebook. I could have as easily send this in a line group, and you guys can go through it yourself. But from my experience, that's probably not the best way to learn. So the best way for you to learn is to open up your laptop, right? Start a new blank page, okay, in Mathematica. Now, what I would like you to do is save that as your student ID name, okay? So you'll be something like 8065, whatever, 1234.nb, okay? Save that periodically. At the end of the class, your TA, I'm gonna have your TA create a My Course View portal. My Course View? Sorry? You haven't got permission. Okay, can you go ahead and get that sorted out? Because by the end of this class, it's going to set up My Course View, and you will submit it, at the end of the class. Don't have to worry about whether or not you get it right or wrong. This is just an evidence of your participation and learning. So we'll count this as a homework, but it's not going to be graded for correctness. Okay. Okay. So with that in mind, let's get started. Again, this is from my kind of like, oops, my notebook here. I'll make it much bigger. Okay, it's a bit slow. In here for some reason. Does that help? Okay, I guess it does. Okay, right. So this is going to be my interactive textbook in data analytics. You can see the subtitle of this text will be interactive visualization, probabilistic modeling, and machine learning with Mathematica, right? So, oops, I'm trying to get rid of this thing so it doesn't keep popping up. Right. So as is with any good text, it's got introduction, what is data analytics, what's data, but to an extent, we already went through this descriptive understanding, right? So this is basically almost verbatim the sort of material that I was going over last time. I don't know what this is. I don't need this. Okay. So good. So just so that I'm happy, raise your hand again that you've got all the software installed, no problem, access code, everything. Good, good. Okay. Okay. So, this is all like wording. You can read that later at some point. Data versus number. Okay. Now, this is where I actually start using Mathematica, although not in any significant way. This is sort of like a review of what we talk about, the data. If you're talking about number is a kind of a measurement relative to a scale, right? So I can, the most primitive scale is basically your student ID, right? So the only thing that we can do with that mathematically is check whether or not it's the same, right? That's it. I just checked your ID. So this is it. The only operation I can do is Alice, the same thing as Bob, right? Now this is called logic. So this actually returns, you know what I should do? I should delete cell, delete our output. Okay, so you don't see the output. Okay, let's do that. Okay, so right. So you can do this. You can say Alice equal or not equal to Bob. Okay, shift enter. Okay, do this on your machine so you get something there. Now, Alice and Bob are not variable names, so I put in double quote because it's a text, but certainly you can do it with anything. Is it true? Yes, it is true. Okay, why? Because Alice is not Bob, Bob is not Alice. So that's it. The only operation you can do is equality or not equality, right? By the way, equality, to check equality, you put equal twice. Okay, equal, false, right? See that? Now, in inequality, it is exclamation mark followed by equal sign. So not equal, and that automatically turns it to not equal, right? Shift enter. True. Okay. Simple as that. That's as simple as it gets. It doesn't get any more simple than this. Okay. So, by the way, technically, this is actually a function call. You're calling a function that is supplied with two arguments. The first argument is the word Alice. The second argument is the word Bob. And that function returns two values, either true or false. Okay. So that's it. Now, I can do all kinds of stuff, right? Now, this is a little bit, again, I want you to replicate the keystroke. That way you have it at your disposal later. Now, what it means is that the left-hand side is ABC, right? Right-hand side, this less than greater than, that is a shorthand for joining. So if I'm going to join two string, A, join with B, join with C, that's the same thing as ABC, right? So that's why this is considered true, okay? Again, so today it's not very insightful in terms of data. It's very mechanical. It's what I call programming primitives. Okay. So but unless you have programming primitives, you can't learn any language. So it might be a little bit tedious. Unfortunately, I sympathize with you, but there's no getting around it. Okay. So let's try this. How about you type this? 120 equal 5. Now, what's the right-hand side? That's actually a shorthand for, well, it's not a shorthand. It's actually a mathematical symbol for factorial, right? You know that, right? So is it, so if I didn't say, if I did this, it's going to say true. But if I didn't put true, I just put this, it's going to give you the result. Okay. Now, here's where it gets really fun. For a big number, a relatively big number, okay, you get something really big, okay? And sometimes it takes seconds to compute. See? You notice the left-hand side, it says input 8, and the top, it says computing. It takes a while to do that. Why? Because you actually take 12 million times 12 million minus 1 times, so this is going to take a while, right? So you can see that the output is still number 7 because it's a previous output. It's going to take a while to get to output 8. Anyway, the reason I want to show you this is that you can actually try this with ChatGPT. Okay. Now, ChatGPT is obviously not going to give you the right number because it's not going to give you the computation. But it turns out to be very clever. It does give an approximation. Very clever. I thought ChatGPT is getting so smart. Anyway, so yeah, so these are the numbers. So it's a huge number. It's a huge number. Yeah. So that's a so good. Okay. So you can do a factorial, right? Now you can check whether or not 3 is equal to 3.0. It turns out to be true, even though they're different data type. Why do I put this down? Because some of you from high school probably did some programming language, maybe in C or something, where the type of variable matters. So whether it's float or integer or something like that. Okay. Now, pi, special character, you can do this. Okay. Go to palette and go to special character. There's a special character somewhere. But anyway, Mathematica knows what pi is. So is pi equal to 22 divided by 7? Anybody? No, it's not, right? It's just a quick approximation you learn in 5th grade, but it's not true. Okay. Now, what else can you do? You can do simple things like now this is where your algebra. Okay, this is like interesting thing that you did in high school, right? You did this algebra thing, expansion. So can I expand it? So let instead of doing it to show that it's true, let's do this, expand. Okay, right? So it's gonna do this front, back, front, back. But what's fun thing is this. What's fun thing is that if you start with this, now you didn't have this true in high school, but if you did, you can say something like this. Factor. I think some of you did this in maybe not 5th grade, certainly not, but maybe like a junior high or something. See? So you can do factor. Okay. So you can do something like factor, I don't know, AX. Yeah, but all kind of stuff. Okay. So you can factor this and so forth. Okay. So this inequality, this blah, blah, blah. Now, this is where I want you to start thinking of Wolfram Mathematica not as a programming language, but as a computational platform. So if I enter something to do, for example, I said, 6 factorial. Okay, fine. It's going to give you 6 factorial. That's no problem. That's no problem. But if you want to learn about factorial function, if you want to learn about something else, instead of Googling it and then sort of like putting it in here, you can use what's called Wolfram Alpha. Okay, so think of Wolfram Alpha as Wikipedia plus Mathematica. Okay, so if I'm interested, I'm interested. So this is kind of example I made in front. But let's say I want to know if human beings, our average human being temperature versus mouse. Okay, for some reason I just came up with this silly example. Okay, normally what would you have to do? You have to go to Wikipedia page, right? To look up human body temperature. Go to Wikipedia page, look up mouse temperature, and get the data, do some computation. Okay. But in this case, with this Wolfram Alpha, it's sort of like both mathematics, so simple mathematics, just minus. Okay. But are you seeing this on your machine? Okay. To prompt Wolfram Alpha, you have to do this. You have to say equal. Oops. Equal. Okay. Go to some blank space. Go to some blank space. Okay. Type equal. You're gonna get this equality sign. Okay. This is kind of like entering formula, but in a verbal English way. Okay. If you type equal, it's gonna become this symbol, right? This symbol takes you to Wolfram Alpha. So now you're in like a search for information mode. Okay, so you can get any kind of data. So let's say something like, I don't know, diameter of Jupiter or something like that. Okay. So instead of looking in Google, you say, well, diameter or something like, yeah, mass is more interesting of Jupiter. Okay. Shift enter. Okay. The difference between this and Google search or Wikipedia is with Google search and Wikipedia, you just get the result, right? Right. Here, what you get is actually quantities or variable that you can do computation on. So let's say I want to calculate how much Jupiter is heavier than Earth. Okay. So I can do this, and this is all ready for you. I'm not going to cover a lot of that today. Okay. I'm just going to show you. You can play around with it. Okay. The idea is that you could equal, and then the subject, think of it as Wikipedia, right? Or Google search. But when it returns you the result, it doesn't just give you the result and you have to copy it and do something. You can do some multiplication. You can do all kind of analysis. Try to play around with it. There's a lot of suggestion here. You can say, do I want to print this? Do I want to plot? Do I want to show this? So this is kind of a very fun thing. Okay. In fact, this is how when I deal with a new project, let's say, as a consultancy, I don't actually work on the same set of problem. Let's say somebody wants me to work on a problem that has to do with, I don't know, distribution of poverty in northeastern or southeastern or southwest of China or something like that. I can look it up here, right? But instead of just looking it up, I can actually take this. I can plot histogram. I can do probability, fitting, all kind of stuff. So this is a wonderful way of starting your project. Okay. Now, of course, if the data is proprietary, for example, let's say, I can access information like poverty in China or something, but if there's a proprietary data set that has to do with poverty of a particular sub-province here inside, that's not going to be available. Then you have to deal with it the traditional way, which is save it as a file, as a table, import it, and do analysis. But data like this, which is very convenient, okay? So immediately you already get something, so so you can do this. Now, let me give you a side note, which is that that ChatGPT it works by associative memory. So it doesn't give you factual information. It doesn't give you the right computation. In future version of ChatGPT, they will try to do this. They try to hook in fact, they already do this on a sort of like a small scale. They hook the front end of ChatGPT with Wolfram Mathematica. So when you ask quantitative questions, instead of ChatGPT giving you a wrong guess, okay, it's going to be a wrong guess because it can't do computation. You can say, ChatGPT, please give me the first 100 digits of pi or something like that, right? And instead of just coming up with association from memory or give me a 125 factorial, instead of just giving an approximation, it's actually going to connect with exactly the same thing you have right now, which is Wolfram Alpha. Get the answer from Wolfram Alpha and then show you on the ChatGPT screen. Okay. So exact same tool is going to be at the back end of ChatGPT for computational problem. Okay. For computational problem. For other things like, what dessert goes well with duck noodles or something like that. That's something that ChatGPT doesn't need to compute. So it's not going to go to, it doesn't have to go to Wolfram Alpha and just search the internet or something, just from memory. Okay. So anyway, so the idea is if you go to a blank page, yeah, maybe I should do that. I could, so that this looks like more what you have in screen, right? When you open it, there's a new thing before you save. You can see that there's a plus here, right? If you click on it, it gives you this option, right? The top one is the default. It's called Wolfram language input. In other words, if you start typing, it's going to think it's a command, just like this is a Jupyter notebook, okay? Except with Jupyter notebook, everything is interpreted as a command, okay? Here, by default, it is a command. Okay. But if you enter it in this mode, again, this mode has a shorthand of equality, then it's sort of like, well, we can try. Okay. This mode, right? This mode. The shorthand is equal. So let's do that. Equal. Okay. This is where you want to enter the command, but you don't remember what the command looks like. So you're making a guess. So something like plot sine wave, please, or something. You don't have to say please. It's not very, something like that. Shift enter. Now it's going to try to interpret it as, oh, is this what you want? Yes. Yeah. If it is, then it's going to do something for you. Oops, sorry. I just did something. Yeah. So plot X. Yeah. So that's what happened. So it goes back to, if you know the language command, this is what you would use. But if you didn't know, you can't think of it. This is sort of like autocomplete, as it were, so equal, plot, a sine wave. Now, once you use mathematical for a while, this is not that useful, okay? Because chances are you can use autocomplete. For example, if instead of doing this, I just type the word plot, yeah, and it makes auto suggestion of the command, okay? So even though you don't remember all the built-in function, just start typing something that makes sense. It's going to try to autocomplete for you anyway, okay? So this one I don't use at all personally, but the equal, this thing I use a lot. Well, not a lot. Yeah, I use when I want to get data set or something like that. Okay, so if I search something like population, Thailand, something. Okay. Now, what's good about this is with large language model, it's just going to give you answer. With this, it's a bit more precise. It tells you what it assumes. So if I say something like population of Turkey, it's going to confirm that Turkey here refers to a country, not a bird, for example. Okay. Now Thailand is already a country, so that there it is. So this, see, it gives you the number, it gives you a graph. Once you have this in this domain, you can do further thing down here. You can take this data, you can do I don't know, histogram, you can do all kind of stuff. Okay. So So now I haven't done anything with meaningful yet. This is sort of like exploratory. Okay, so male population, and it's gonna demographic of Japan or something. I don't know. Yeah. So this should be your first place when you try to get some data, rather than Wikipedia or whatever. Okay. Again, if it's something very specialized, it may not. Okay, it may not. But right now, yeah. Now I want you to show you this. Before it gives you the result, it actually gives you the command. So if you actually knew how to access data set has to do with demographic of Thailand, of Japan, you would just type in data set and then Japan or whatever. Okay, so that would have been your command. Okay, but it's just kind of reinterpreting the command. So right now, Japan has that so many people and so forth. Okay, so this is kind of like a fun thing. Well, more than a fun thing. So this, you can play around with this. Okay, and just save it. And again, at the end of the class, save it as your student ID, right? Student ID 80651234.nb. Okay, and then submit to the my course view that your TA will send the link to, I guess. Okay. Okay, so this is something that you can play around with, but I'm gonna go back to my notebook. So these are sort of stuff. Okay. And it's not just quantitative. You can anything you can think of. I think in the book, I like to introduce some interesting fact in science or history or something. And one of the guy that I think is overlooked in I think in mathematics is a mathematician named George Green or something. So I think in my book I use something like equal. Oops, sorry. Okay, but anyway, you can do anything. You can say equal, oops, equal, okay, equal, okay, Einstein, okay, shift enter, and it's gonna say, well, I assume this is a person. It's gonna give some background biography or something like that, so you went to watch a movie, Oppenheimer, you can say, when did he discover this or that? Actually, he didn't discover much, but he was working on a black hole implication of Einstein equation. But that's one thing that the movie got right, actually, very good. Many things the movie got right. Okay, so this becomes biographical information, right? So think of how cool this is. You don't actually, in one place, you almost have like a built-in Wikipedia, except anything that is quantitative. Let's say there's something about his, well, Einstein biography is not going to have much quantitative, but again, earlier you saw, things like this, you can do computation. Okay, so this is why I'm introducing this as a very good data analytics platform. Okay. Again, you don't have to show me your hand, but some of you, I'm sure, are not doing applied digital intelligence, but doing, say, health and well-being, right? So you would like to know something like demographic of people in Thailand, how old, young people, COVID spread model, all kind of stuff, right? Instead of just going and search on the World Wide Web and then download as an Excel or as a CSV and upload here, and if it's here, then you already got the data well clean. Okay, so it's very cool, very cool. Okay, all kind of stuff. But again, Mathematica is like iOS, so it's a bit of a closed system. So if it doesn't have it, you have to look elsewhere. Okay, it's a bit like iOS, so it's not as big a community as Android or Python. Okay, so that's the downside. Okay, so this is something we got. So yeah, got a little bit of this. Go to the next page. Okay, now I'm going to talk about numbers. Okay, and before I get to number in general form, I just want to tell you that not all numbers are created equal, right? What's the most basic form of a number? The basic form of a number is a number. Okay, that number is a measurement according to some scale. That's why a single number is called scalar, right? One number. One number by itself is called scalar. Now, a scalar is just a number, like 3 is a number, okay? 3 is a number. Can that be used to represent your coordinate in 2D? No, because I need 2 numbers, okay? So one number, a single number, is a scalar. That's not good enough. That doesn't do much. I just wanted to show you this. This is kind of like asking, what's the matrix? I can do this. But I'll go to vector and I'll come back and it would make sense. Okay. So the most basic form of object, mathematical object in here, as well as in life, that you're going to see all the time, again, is a vector. Remember I told you the most common data structure in your lifetime is a table, right? What's a table? Well, you have an ID and you have a whole bunch of numbers. Okay, now let's say I have your ID and the first number is height. The second number is weight, right? I'm associating you with what number? 2 numbers, right? So can I represent you with a scalar? No, because that's not enough, right? I need a 2-dimensional vector to represent you because you are represented by your height and your weight. What if I'm a doctor? I take your height, I take your weight, I also take your temperature, I also take your blood pressure, I also take your sugar blood level, let's say. Okay? So there are actually 5 numbers. 5 numbers. So this becomes 5-dimensional vector, or a vector with 5 numbers. Okay? And if I have you, I have somebody else, I have somebody else, I have somebody else, I have somebody else, I have 1,000 people. What I have is an Excel sheet of 1,000 row and 5 column. Well, 6 if you want to add the ID, okay? But the most basic form, again, in mathematics, in any kind of analytics, is vector. So get comfortable with vector. Now, fundamentally, what's a vector? Again, a vector is a couple of numbers. Not one, but maybe 2, maybe 3, maybe 10. Okay? Maybe 10. In the language, how do you list the element? You use curly bracket. Okay? So let's go back to a blank page. I like this blank page. So if I say my height and weight is equal to open bracket. Okay, now you can put in your own height, your own weight, right? Open bracket, that's the curly one, right? Notice that if you enter the left one, the right one comes with it because it automatically assumes, again, this is just user interface, okay? So what's my height? So let's say my height is 169 centimeter, comma, what's my weight? So let's say I weigh, say, 70 kilogram or something like that, okay? Something like that. Now, so in terms of height and weight, I am a two-dimensional vector. But if I take something else, what was I talking about earlier? Let's say my resting heartbeat. My resting heartbeat is 73 beats per minute, let's say. Okay, I'm not very fit right now. So when I was fitter, it would have been, maybe could have been 60 something, but now it's 60. Okay, so now what's important about this is that a list here is just a list of number. If I don't give you any context, do you know what it means? No, you don't, right? So you have to understand that this is not data quite yet, right? This is a mathematical object called 3 numbers, right? But when you work with it, you have to understand what it means. So somebody else, maybe somebody else, okay, can have taller, heavier, or a resting heartbeat of 56 per minute or something, 56 beats per minute. So basically, if you have lists of this, it becomes a tabular data. What does this tabular data contain? It contains hundreds of people with height, weight, and heartbeats. Okay? You can use this as your data. Then you can do all kind of stuff like what's an average height of this population? What's that mean heart rate? So that's basically everything you do. Okay. So you're dealing with data, but data at the not microscopic, at the individual level, invariably comes in the form of a vector. Okay. Now this is very important, guys. This is very important. You have to trust me. I told you last week, right? We're doing big data. Sometimes your data is a picture. Sometimes your data is voice. Sometimes it's sound. Sometimes your data is text, right? But fundamentally, when you want to do something with it, you have to kind of like convert all this into a vector. Okay? And this is the key. It's like when they invented electricity. Okay? Everything you want to do, turn on the fan, turn on air conditioner, everything has to be converted into some kind of common language. And that common language is 120 volt or something like that. Okay. Same thing here. It doesn't matter what the original form of the data is. If you want to do something with it, ultimately, when it gets to the computer, before it gets to the computer processing, it becomes a vector. Okay, it becomes a vector. Okay, so even Alice is a vector. Okay, yeah, your picture is a vector. Okay, let's say you don't believe me. You don't believe me. Let's say you don't believe me. Your picture is a vector, and I say your picture is a vector. You don't believe me. Well, think about it. Your picture, once digitized, is 1,600 pixel across, 1,000 pixels long, and 3 colors, right? So it is what's called a tensor. It's 1,600 times 1,000 times 3. But when I get this to the computer level, internally, quote unquote, it becomes 3 numbers, 3 numbers, 3 numbers, 3 number, 3 number, 1,600 times, and then 1,600 more times, and you do this 1,000 times. So it is a long vector, very long vector, but it is a vector. Okay, so you have to get to the idea that reality, if you want to do any kind of analytics, any kind of data, any kind of computation, if you want to digitize it, ultimately it is a vector. Okay, it is a vector, but then you have to understand, right, that the first number is red, second number is blue, third number is green of this pixel, and the fourth number is red of that, the next pixel. You have to do this right mapping, right? Otherwise it gets out of context. Just like here, 73 here. I don't know what that is, but if you're working with it, you have to know that 73 here refers to how many heartbeats per minute when I'm resting. 70 here refers to my weight in kilogram. 169 refers to my height in centimeter. Okay, so that's the context, right? But anyway, what I want you to do is, what I want you to know now is that a vector is everywhere. Get used to it. Okay. Now, in the same context, the vector will always have the same dimension. That's another point I want to make. In this context, I'm treating you as a height and a weight. So I only need 2 numbers from you. But if I'm going to be a medical doctor, that's not good enough, right? I need your heartbeat and blah, blah, blah. So in a different context, a person is 12 numbers. Okay? I'm a doctor. If I'm treating you for cancer, I probably need you more information. Each patient is 25 numbers, right? Right? But if I'm just trying to measure your pant size or something, your shirt size, I'm trying to sell you a t-shirt or something, then I just need your height and maybe your waistline. Everybody's a 2 number. Okay? So that's that. Okay, so play with that. So this is a concept of a vector. Now, so I'm going to put generically. Okay, generically, this is. So it is a bracket. Oops, where am I? You need to. I think you might have to make your mouse like really big or something. Like not the mouse big, but the trail. So I can't see. I can't see here. It's very dark. Okay, so this is a 3 number, right? This is a 3 number. Now, raise your hand if you've done matrix algebra. I think I asked this already. Okay, you remember, right? In matrix algebra, a vector doesn't look like this. Okay, how do you write a vector? You write it as a. Yeah, exactly, right? So what I have to do is, let's say I want to show this as a matrix algebra or linear algebra form. I have to say matrix form. Okay, matrix form again. See, I start typing. I don't know. The thing doesn't know what it is. It's blue, right? I put in A. Look, it's autocomplete, right? None of this is what I want. So T. There it is. There's a third one. So actually, if I go down to the third one and I just enter, right, it becomes a built-in command. Okay, and a built-in command is in the letter black because it knows what it is. So matrix form of. Now, put left bracket. Now this one is a function. So in Mathematica, the primitive way of calling a function is not a round bracket, but a square bracket. Yeah. So now you know 2 primitives. Again, I apologize. This is probably one of the most boring class you'll ever take, hopefully in 4 years. Okay. Oops. Okay. So the first bracket you have to know is a curly bracket. That gives you a list. The second you have to know the second bracket you have to know is a square bracket. It say this is a function. Okay. This function say, give me something. I'm going to draw it in the format. Form here is short for format. So I write 169 and 70 and 73. Shift enter. There. Okay. So this function doesn't give anything except it just gives the right format. So it looks nice. Okay. It looks nice. Okay. Right. Okay. Now, sometime if you have a function and you only need some function takes more than one argument. Okay, most function takes more than one argument. But if it just takes one argument, sometimes you write something like this and it looks a little bit superfluous. So there's a shorthand. Okay, instead of having an open bracket and close bracket, you use the word application. So I can do this. Oops. Application. Okay. Get the same thing. Exactly same thing. Okay. So for univariate function, instead of open bracket, close bracket, just say at. Okay. It doesn't stand for at, it stand for apply to. Okay. Now, some of you who are a bit more advanced may have learned of this thing called pipe. In computer science, a pipe is like a processing. Think of things as processing. Give me something, I do something. Okay. So give me this thing and I pipe, and that's / matrix form. Yeah, same thing. Okay. So type this so you don't forget. Okay. So now you learn the curly bracket is where you store a list. Square bracket is where you put in an argument. And if you only have one argument, sometimes you just use apply, right? Or you can do this. Okay. Now, what's nice about this is that you can do things in series. So for example, instead of taking a matrix form, okay, I take the summation first. I say total. Okay. See? It takes the left-hand side, which is, okay, this doesn't make sense, right? Nobody adds height to a weight, but let's say it makes sense here. I take this, I add the total. The total comes to 3112, and I put in matrix form. Now, because 3112 is a scalar, the matrix form is just what it is, right? It's just what it is, okay? So sometimes I do a few things in one line. Now, let me show you how tedious this would be, okay? If I have to do it in multiple lines, okay? My information is equal to 169, 70, 83, okay? And to separate between line, okay, this is a thing I think I may have mentioned last week, but say it again, semicolon, okay? A new line, sum of these is equal to total of my info, okay? And matrix form of this, format of that is equal to matrix form of sum of these, okay? Now, let me show you. Okay, watch my hand. My info right now is blue because the computer doesn't know what it is. Once I shift enter, then it knows what it is. It becomes black, okay? So my info is 3 number, semicolon, that's just to say, next line. Some of this is total my info. So take that and add the 3 numbers together. And the bottom line is matrix form. So you take something and you have 3 lines basically, right? So what does it do? Now, if I don't put in semicolon, it's just going to give you the final result. There it is. Oops. Oh, the number is slightly different. Never mind. Okay. Now, why would I do this in 3 lines? Well, I would only do this because if I need to access the intermediate value first, somewhere else, somewhere in the next part of the program. But if I don't need it, I only need to do this once. Would I write 3 lines and name new variable? I wouldn't, right? Okay. Same thing, right? When you go to a doctor and the doctor takes your temperature and you wait, just text it and write on the sheet. Doesn't actually write in something and then transfer it to another file, do something. It's stupid. Okay, I would do this kind of thing if I need the information later. If I don't, I'll just do this. I'll just say this. Okay. Now, the opposite. Again, this is not very structured, but the opposite of this is a total at. Now, what I did was use pipe, right? But I can also use at as well. So I can do this. Take the total and then takes matrix form. Get the same number, right? Okay, so you can see why that a lot of this is a one-liner. Okay, so it's a lot of one-liner, and it's very easy for you to read because you can say, oh, I'm doing things in sequence. I'm taking the total, then I'm taking matrix form. Okay, fine. Yeah, so now, yeah, you should know this curly bracket. You should know square bracket, right? You should know at sign. You can know this sign. You can know. You also know the semicolon for next line, right? Okay, so those are. There are actually no more than 10 symbols you have to memorize. So these are the primitive, okay? Once you get this, everything else is just easy, okay? But you have to memorize. It's like in English, right? You have to learn punctuation, apostrophe S, a comma, a dot for period, for end of sentence. If you don't learn this, then you're not operating the right rule. The question mark, the exclamation mark. So there are about 8 or 9 of those in a typical language. Once you memorize what it is, then you can read any computer code. Yeah? But unfortunately, for the first class, it's a little bit boring. Okay, but you have to do that, right? So this is like the first time you're learning English, you have to learn a punctuation period. Okay, now, what if I have, okay, you know linear algebra, right? So you know what a vector is. What about a matrix? Okay, a matrix has not one number for dimension, it has 2 numbers for dimension. So if you have a 2 by 3 matrix, what do you have? Think in your head. 2 by 3 matrix is a matrix with 2 rows. Each row has 3 columns. So how many numbers do you have? 6 numbers, right? So let's do that. So this is because ultimately you have to write everything in a bracket. Same with the matrix. How would you write that matrix? Let's say 2 by 3, right? We talk about 2 by 3. Let's say A, B, C, D, E, F. How would you write it? Well, common sense say, what's the first line? What's the first row? A, B, C. Okay? So it's a list of lists. Comma, C, D, O. C, A, B, C, D, E, F. Okay? That's it. That's matrix. Right? That's how many rows does it have? 2 rows. How many columns does it have? 3 columns. Okay. Now you said, oh, that doesn't look pretty. Okay, fine. You think it looks pretty. So I'm just going to make it look pretty. Again, I lose your mouse. Okay. Matrix form. Is that pretty now? Okay. It's pretty now. Okay. But again, when you use it, you don't have to write this matrix. This is only for like printing or something like that. Okay. Now, as you know, a 2 by 3 matrix can multiply whom? A vector, right? So let's do that. Let's do that. Now, this is another symbol you need. So how do you multiply in a vector? In a linear algebra, you use a dot product, right? So here it is, dot product. Dot. Now, I have to multiply by something that has the first number is 3, right? The first dimension is 3. So I can say something like, I don't know, F or G H I, okay? That's it. Right? Right? So this here is a matrix. It's a 2 by 3 times a vector. Now, obviously, this again doesn't look pretty. So let's make it look pretty. Again, I'm printing or something. Right? Okay. So, so now today you have the primitives. You can do linear operation. Okay. You can need linear operation. And of course, you can do a lot more. You can do a lot more. For example, now let me, you guys know how difficult it is, right, to do a matrix inverse, right? So let's say I have a 3 by 3 matrix. Now, matrix inverse has to be square, right? I can't find you. Okay. So let's make this matrix GHI. Okay, so that's a 3 by 3 matrix. Okay. By the way, you can check for dimension. You can check for dimension using a function called dimensions. So instead of dimension, 3 by 3. Okay. Anyway, so well, in high school, the toughest thing you had to do is inverse of a matrix, right? Right? So this is very easy. Okay. Take this matrix and do matrix inverse. Oops. Is that it? The third line? I can't see very. Oops. So now it's inverse Fourier. There. Inverse. Okay. That's actually. Now, it looks horrendous, but it's certainly a lot nicer than if you had to do it yourself, right? So let's look at what it looks like. The whole idea is that the computer does the thing for you, so you don't have to worry about it. Again, I can't find. Okay, matrix form. Yeah, that's it. Yeah, now that's what it looks like, right? Now you can put in real number. Let's put in real number. I don't know, 1, 2, 3. 1, oops, 2, 3. Okay, and then, well, you get my point. Okay, you can do this, and it's going to put in number 4, 5, 4. Yeah. Again, save this as evidence of your participation, but you don't have to. So any number, right? Now, the nice thing about this is that in real life, you're not going to be dealing with a 3 by 3 matrix. You are going to be dealing with 100 by 100. Okay. Okay. Raise your hand if you have no idea how you're going to see 100 by 100 matrix in your life. Or raise your hand if you can imagine how you're going to deal with 100 matrix, 100 by 100 matrix. Well, how about social network? There are hundreds of you, right? Right? Basai student, right? 100 at a time, okay? If I list you by order of your student ID, okay? And IJ is equal to 1 if the student I is a friend of student J. Okay? So let's say your ID is 3 and his ID is 4. Okay? I go down to the third row, go to the fourth column. You don't know each other, that value is 0. But once you knew each other, that value becomes 1. So this is 100 by 100 matrix of 1 or 0. Okay? Now, let's say it's something more meaningful than that. Instead of saying, do you know him? I ask, how many years do you know him? Okay. 0, you don't know him. 0.25, I've known him for 3 months. Right? So now I have 100 by 100 matrix of real number. Okay, so this becomes your matrix. Once this becomes your matrix object, you can do all kind of stuff in Mathematica. You can do centrality analysis, who is the most important person in the network. Okay, you can do all kind of things. Chances are you have more than 100 friends in a Facebook. Okay, so right now you actually have assigned to your individual data point maybe a 300 by 300. Okay, so if I have a community of 20,000 person, then you personally in your own row would have 300 ones, and everything else would be 0. I probably have maybe 50 friends. I have less friends, so my row would have a lot of 0 and maybe 50 ones. Okay, somebody who has 1,000 friends would have 1,001, and obviously, right? So this is how. So this is how you process a matrix, but a matrix is a list of lists. And again, I said earlier, once you get to the computer level, it's actually a vector. Okay, but you don't have to go that down. Okay, so there it is. It's a vector. So this is okay. So these are examples that I made. Now, why do I spend so much time on just this page? Because as a data science class, as a data analytics class, the most important thing, there are two most important branch of mathematics you have to learn, right? I did last class. One is linear algebra. So basically this thing, matrix, okay? The other thing is calculus, okay? We'll go to calculus in very briefly, okay? Hold on, let me see. How are we doing on time? Dimitri, I'll let you do the timekeeping. Okay, we good. Now, yeah, generalizing data. This is all text. I'm not going to care so much. Okay, so this chapter, I might actually send you like excerpt from this because you should read, because there's some link as well. Okay, so this is basically introduction to mathematics. Okay, this is the one that I was telling you about, that you know, I can say something like equal global warming equal George Green. This is a guy that I think that people don't know, but you should know. It's interesting. Okay, so yeah, to an extent, we already did this a while. Global warming, okay, for example. So when instead of looking up global warming, you use Wolfram Alpha. It gives you data, it gives you plot, it gives you a ice age, it gives you all kind of stuff. Okay, so we did that already. Sorry. Yeah, I should have come to this page for that example. Okay. Okay. So now we're gonna march. So you've already started using like some functions. So I'm gonna march through this thing fairly quickly, right? So what's the most basic, most primitive operation you can do? You can add 2 numbers. Okay. So 1 plus 1 is equal to shift enter 2. If you put a semicolon for next line, what it's gonna do is just gonna give you nothing. Okay. That doesn't mean that it doesn't give you 2. It already got 2, but because you put semicolon for the next line, it just clear the line. Okay. So now, this is something I don't use very often. Some of you may find useful. If I use a symbol percentage, what it means is that it goes back to the previous output. Okay. And if I do something like I don't know, because that's going back 5 output. I don't do this a lot. Okay. Or I can do something like go to line number 5, what I got before, and this was some number. I don't know what it is. Sorry. 5. Okay. Apparently that was the 5th command. Okay. So this kind of percentage is sort of like a backlog. Okay, it's like when you work with DOS console, you can go backward. It's the same thing. I don't use it a lot. It's not very useful, but I just thought you should know. Yeah. Oh, the reason I tell you some of this is because when you go to a discussion group, sometimes they'll give you codes and it will contain this kind of shorthand. And so if you see it, oh, it looks like a funny shorthand I don't use. Yeah, that's why I have to teach you. But it's not that useful, this thing. Okay, right. So this concept of putting one operation in a little thing, you go to the right-hand side, you put your mouse to the right-hand side, you can see this thing, right? This is called a kernel, okay? A kernel is an English word. It came from the same word as a kernel of corn. Basically, it's a nut, right? When you go to an oak tree, it has many kernels, so many nuts. So this is the tiniest unit of computation is a kernel. Okay? This is a very successful way of interacting with a computer, this kernel-based notebook. So when I think later in the 80s, when people were developing what's called a Python user interface into what's called Jupyter Notebook, they copy this concept from Mathematica. And so if you use this in Mathematica and you go to Jupyter Notebook, you would see that it has got the same kind of structure. Yeah, but not every Python user interface follow this kernel. But again, I would because I'm used to using kernel. So if I need to program things in Python, I don't use any other kind of interface. I use a Jupyter Notebook. Okay, and I think Jupyter Notebooks become very popular. I think you go to Colab and stuff, it's always in a kind of notebook form. So yeah, so you can see that it has got this bracket and it's got bracket or bracket. So what it does is that it kind of bunches things up together in a unit. See? So for example, I can say that this is a big unit. See, this is a big unit. And if I double click here, it just hides everything. Okay. So this is actually, some version of Jupyter Notebook in Python does this, but most of them don't. Okay. But this is I find this very useful. So I can hide the detail, as much detail or as little detail as I can. So I can hide at that 1 level, 2 level, or can go all the way, nothing. Okay. So this is very good because when I do consultancy work, I don't need to show the underlying code. Just need to show the result. Okay, fine. So these are numbers. Okay, this is the past access. Right. Now, the first thing you need to know is that equality is an assignment. It's not a question. If I say Alice equal to Bob, right? I use double equation, right? Equal. So I ask if Alice is the same thing as Bob, and the answer is no. Okay, but I'm not saying Alice one equality sign Bob because that would be assignment. I would say Alice is equal to Bob. It's an order, it's command. That command only use one equality. So if I say X equal to 1, now let's go back to what we did earlier with 2 double. Okay, if I say X equal to 1, okay, what do you think is going to happen? Right. Well, first of all, X is blue because it doesn't know what X is, right? So asking the computer, is X equal to 1 is meaningless. So the computer say, I don't know. Is X equal to 1? It's kind of like a tongue in cheek. Instead of saying, I don't know, it just gives you back the question. Is X equal to 1? Is X equal to 1? I don't know. Okay. Now, if I assign X is equal to 1, watch this. X is blue, shift enter. X becomes black. It knows now what value that is. Now, if I go back to the same command before, X equal to 1, then it would say, oh yeah, it's true. Right? Okay. So equality and double equality are two different things. Mean very differently. Okay. So yeah, that's simple as that. Again, these are primitive. Today you're not learning anything that meaningful. So this is now what if I do this? X is equal to X minus 3. What it does is take the original value of X, subtract 3 from it, and then assign it again. So you overwrite. So 3 becomes minus 2. Okay. Now, Instead of x is equal to x plus 5, I can do this. This is a shorthand. Again, I'm showing you a lot of shorthand because you see this in discussion groups all over the internet. So x plus equal to 5. So it used to be 2. Now it's going to be equal to, well, it doesn't say anything because you put colon, right? So put 3. Right? So you can do this with anything. X multiply equal to 10. 30. Okay. So that's a shorthand. So x is equal to x times 10. Okay. Now, once I do this, okay, notice that y has a value, okay? Maybe y has a value. So I want to clear the value. So now if I say clear all, what is clear? X and y becomes blue again. Okay. Why would I do this? Because x and y is so common to use, right? I can use this to represent something temporary. But if I use it again in the later context, it's going to have a value. So I have to clear it. Okay? Because once you define it, it's become permanent. Okay? Now, when you turn the computer off or you turn the program off, it forgets. But until you close this session, it remembers x is equal to 1. So I have to clear it first. Okay? Now, is there a nicer way of dealing with this? Yes, I'll show you later. Okay? So again, what I want to do is before we take the break, just cover all the idiotic, simple, primitive, equal sign, that sort of thing. Now, let me tell you that fundamentally, everything in Mathematica is a function. In computer speak, it's called functional programming paradigm. Okay? Python is a functional programming paradigm language. Okay? Python can do object-oriented, but not very well. C++, by the way, my language, I didn't use Mathematica or Python for my PhD. I used C++ for my PhD. That C++ follow what's called object-oriented paradigm. So that's something else altogether. So just so you know, there are many ways of speaking to computer. Okay? Some language communicates with computer as if computer is a mathematical machine. And if you communicate with a computer as if the computer is a mathematical machine, the language that they understand is function. Right? It's function. Just to give you an example, if I want something done by a machine, I have two choices. Use the function that the machine already understands, like, matrix form, that's a built-in function, right? Total, that's a built-in function. But if I want to do some more complicated function, what do I have to do? I have to define the function first. And then, analogy would be something like, if I want an omelet, Mathematica knows how to make an omelet, I can call it an omelet function. But if Mathematica doesn't know souffle function, which is a very sophisticated omelet, okay, you have to define souffle function as a function that requires something similar to an omelet, but more sophisticated or something like that. Once you define this, then you can call it as a function. But fundamentally, every interaction you have with the computer is a function. Okay? So, go get me a coffee would be something like, you know what a function coffee making is? You know what a function go get is? Okay, I'm going to ask you to do this function. Go get, open bracket, make coffee, close bracket. So make coffee and then get it, or get it and make coffee. I don't know. Okay? So every interaction with a computer is through a function. In fact, that curly bracket that I told you about is a definition function. You're defining a list. So the real function is called a list. So if I type in this function, list ABC, what's the output? The output is a list. Okay, so common sense say I'm listing ABC. Okay, common sense say I'm listing ABC. But fundamentally, now you may ignore this because it doesn't really matter very much. fundamentally, I'm calling a function that say, I'm going to give you 3 things. I want you to put that in a list. Okay. So this is what I wrote earlier, open bracket ABC, but the computer understands it as a function call. Okay. Now, some of you may find that interesting, or some of you not. Doesn't matter. The point is, list is the most fundamental way of defining an object. Okay, you already saw that, right? A list can represent a vector. A list of lists can represent a matrix. A list of lists of lists can represent a tensor, right? Okay. And fundamentally, if you flatten everything, right, you can get 1,600 times 1,000 times 3. You can line it all up into one long string of number. Okay. That, by the way, is also a built-in function called flatten. Okay. Let me show you. So we had this earlier, right? So if I say, instead of matrix form, I put in flatten, guess what happened? It lists all this in one line. Okay. So instead of having 3, 3, 3, it just lists everything. So this is called flatten. Okay. Right. And this is actually how it gets stored in there. Right. So the most important object, okay, is a list, because it represents a vector. A vector can represent matrix. A vector can be used to represent tensor. And I just told you for the 100th time today, okay, that fundamentally everything you'll be working with at the end of the day becomes a vector. Okay, even sentence becomes a vector, believe it or not. Yeah, but I'll show you how that works. So when you type in something like a chat GPT, you enter keywords, right? You think that chat GPT is seeing words you're typing? No, chat GPT doesn't see that. You type in how are you, that how are you gets converted into a series of vectors. And chat GPT reads that. Chat GPT also answers in vectors. And then that vector becomes word that you can see. I'm fine, thank you. Okay. So in your modern life, in digital life, everything is a vector. So that's why you need to know vector very well. Now, once you have a vector, what if you don't want all the vector? You want just the third element of it, right? That's called taking the element. Okay. So taking the part. So if I have, say, something like, let's do from a clean sheet. Again, you should do this. Okay. My vector is equal to A, B, C, right? Okay. What if I want to take just the third one? So I say part of my vector 3. Okay. So I take the third one. Okay. Now, this is kind of clumsy and you use it all the time. So they have another shorthand. Okay. It's called double square bracket. So instead of doing this, I say my vector double square bracket 3. Okay. Now I think in Python this is curly. It's kind of like, gets confused if you have too many languages at once. Okay. Notice it's a double bracket. It's double bracket. What it means is that it takes the third element. Okay. So be comfortable with the list. Be comfortable with accessing. Now let's try this. Let's try my matrix. It's equal to A, B, C, F, D, E, F. Okay. Oops. I forgot comma here. Okay. Right. Now, if I want this guy by itself, how do I say it? I want D. I would have to say my matrix, open bracket, okay, Where's D? First column or second column? Oh, sorry, first row or second row? Second row. Which column? First column. Okay. So this is basically IJ when you learn matrix algebra. Okay, that's it. That's all it is. IJ. Now, okay, here's a cool thing. What if I don't want individual element, but I want the whole column or the whole row? Well, I can do this, right? I want the second row and I want all of it. So I type the word all. Okay. Again, the more you type on your own thing, you don't have to take picture from the screen. You can just type it. My matrix. What about this? What about all, comma 1? What do you think I'm going to get? All, comma 2. All the row, second column. Right? Right? Now, let me do something. Okay, let me do something. Sometime I don't want just 2 or 3. I want like a whole bunch of them, 1,000 of them. Okay, I want to create a 1,000 by 1,000 matrix, but I don't have the value for it yet. I just want to create a variable. Okay, so what I can do is use this function called my big matrix is equal to array. Yeah, array of say A, comma, let's make it 20 by 20. 20 by 20. Okay. So what it's going to give is an array of A with 20 row and 20 columns. Okay. So a whole bunch of them. Okay. Whole bunch of them. Okay. So this is my creation. I just created it. So I don't want to print it because sometimes it's take too much space. So I'm just going to put semicolon. Again, I can't find the mouse. Where's my mouse? Yeah. Now, yeah. Let's say, what's the dimension of this guy? My big array. Actually, let's do this. And you see this a lot in my code. I make an assignment inside and I bracket it with a function. Now, this one is a little bit idiotic because I created the function, so I know what it is, right? So I created an array of 20 by 20, and I asked what the dimension is. It's obviously 2020 because I created it. But sometime, this is what I do, okay? Instead of do this, I would say something like dimension my data is equal to import blah, 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 dot CSV, okay? Something like that, okay? So I would import the data from a spreadsheet, okay? But right after I import it, I want to know how big of a table that is. I just do that, okay? Oops, CSV. So this would be something like, this is the sort of thing that you would do every time you do data, okay? Again, you can use Wolfram Alpha to get the data and then play with the data. But if you're going to work with proprietary data or data that's not public, data that's not well-known, data that's not built in, you're going to have to save it in a CSV or in Excel or something like that, and then read it. And the way to read it is called import. But we'll show you later. Anyway, so what if I want, okay, watch this. What if I want my big matrix, okay? I want third row, and I want the 7 to the 11 column. How would I do that? Okay, now this is almost the last thing you have to memorize. You want to go from 7 to 11. Here you use semicolon twice. Okay, so this means third column from 7 to 11. Okay, see that? Third column from 7, 8, 9, 10, 11, 12. Oh, 11, sorry. Okay, so that's another thing you have to memorize today is double semicolon from the left to the right. And here's a fun thing. What if I don't specify the right? What do you think happens? What do you think happens? Okay, I write like this, and I just leave out blank. Well, it just goes all the way to the end. Right? 20. Likewise, if I go to 11, and I don't specify the beginning, where do you think it's going to start? 1. Okay. So a lot of this, I'm showing you now, but it's common sense, right? Common sense. Okay. So if I leave out both the beginning and the end, what's it going to do? Leave everything. It's the same thing as all. Same thing. Okay. So these are the basic primitives that you need. And yeah, there's one more, but I'll teach you after the break because it has to do with function definition. Okay, so let's summarize. What are the symbols that you got? You got curly bracket. Curly bracket. You got square bracket. You got semicolon at the end. You got double bracket. Okay, now except double bracket, you got what else? You got at. You got this. You got semicolon twice, and what else? That's pretty much it, right? All the signs. Okay, so these are the basic boring stuff you got. Why don't you take a 5 or 10 minutes break, and we are going to do things. Well, it's not going to be much more interesting, but certainly it's going to be more interesting than this. Again, everything you do in a computer is through calling a function. Wolfram has 20,000 built-in functions, let's say, maybe 5,000, I don't know, but a whole bunch, you can't find them all. So it's going to do a lot of things for you. Okay, it's going to do a lot of, it's got built-in recipe for doing things, amazing things. Building a neural network is a function. Okay, analyzing a data, regression, plot, all kind of stuff is built in. But if you're going to do that, then Mathematica is nothing more than a quote-unquote fancy calculator with built-in functionality, right? Your job when you're doing data analytics is to analyze using those built-in functions, okay? But the way you do it is going to require different steps, okay? So yeah, there's histogram plot, there's a logistic regression, there's testing, validation. So all this may be built in, but the way you do it for this particular set, for this particular plot, you are going to be customizing it. Okay? You are going to be customizing it. It's like if you go to a friendly neighborhood deli, okay? They can make you any kind of sandwich, right? But every time you come in, you say, I want my special sandwich to be half the mayonnaise with the bologna, but maybe with a little bit of chives, but not too much, and a sprinkle of crushed garlic with onion. This long recipe. Individually, the deli guy can make it for you, right? Cut the salami, take the bread, toast it, or put the chives and anchovies, or God knows what. These are all basic built-in functions. But your special sandwich that you really like takes 10 of these different functions. Every time you come in, you have to order that 10 different instruction, right? But if that deli is a friend of yours or you've done this so many times, right? What do you do when you come in? The usual. right? The usual. Well, by saying the usual, you kind of wrapping all those functions. Take this kind of bread, toast it slightly, put chives and some of anchovy, but not so much, a bit of salt, a bit of pepper, all kind of instruction. Okay, but it's special to you. So you come in, you say, the usual, please. That's what coding in Mathematica and in a lot of functional languages. Okay, you use built-in because the basic primitive are more complicated than you think. Building a neural network is not easy, but to say, take this data set, make a plot, do this, do that, do this, do that, do this, do that, wrap it under the whole thing. That's what's called user-defined function. Okay, so you go to a deli, getting toast, getting anchovy. I don't know why I keep saying anchovy, salami or whatever. That's built in. That's built in. But the special recipe for your sandwich, that is user-defined. Okay, and most of the time, that's what your coding job is all about. Okay, so we'll come to that. We'll come to that. Okay, so why don't you take a little bit of break? When we come back, we'll go to user-defined function, and that will take us to the rest of the period.